The James Webb Space Telescope is one of the most powerful space observatories ever built by humanity. This device is equipped with an optical system and advanced scientific tools, capable of observing through dust and gas layers. And it can observe objects billions of light years away. Recently, scientists have published a study on the James Webb Space Telescope. Traces of human civilization can be detected on Earth, even if it's in another star system within the Milky Way. This discovery raises hopes that the most advanced probes could find extraterrestrial civilizations when it reaches toward the distant worlds in our Milky Way. Since its launch in late 2021, this Webb project has primarily focused on exploring the darkest regions of the universe in search of clues about the formation of the early cosmos. Additionally, one of the secondary objectives of the telescope is to study the atmospheres of nearby exoplanets or planets outside the solar system. Accordingly, this website can search for gases produced by living organisms. The chemicals produced by advanced extraterrestrial civilizations are called technosignatures, while the natural signs of life are called biosignatures. But even with the most advanced telescopes currently in operation, it remains unclear how effectively the James Webb can detect signs of intelligent life. To answer this question, scientists conducted an experiment to determine whether space telescopes could accurately detect traces of human civilization on Earth. This is also the only planet in the universe that we know of which is habitable and currently inhabited by humans. In a newly published study on the Open Access Database Axis, scientists conducted a spectral analysis of Earth's atmosphere. However, this spectral data has been intentionally degraded in quality to simulate the perspective of an observer located tens of light years away. Next, the research team used a computer model to simulate the sensing capability of the spiderweb network, aiming to test whether the telescope could detect key biosignatures and technosignatures from the dataset. For example, space telescopes must detect the presence of methane and oxygen produced by biological activity, along with nitrogen dioxide and chlorofluorocarbons generated by human activity. Notably, the non-peer-reviewed study results indicate that the Webb telescope is indeed capable of detecting all key signs of life, including both intelligent and non-intelligent life, in Earth's atmosphere. Researchers stated that the adjusted Earth dataset, now skewed toward worse conditions, is nearly on par in quality with data obtained from the James Webb Space Telescope when observing exoplanets in the Chart T1 system. This is a star system consisting of 7 exoplanets orbiting a red dwarf star located about 45 light-years from Earth. This proves that the James Webb Telescope is capable of detecting life or extraterrestrial civilizations within a 45 light-year radius from Earth. But researchers believe Z-Webb could also detect signs of extraterrestrial life in star systems up to 50 light-years away from us. To date, only about 20 exoplanets have been confirmed within 50 light-years of Earth. However, based on the number of suspected stars in this region of space, experts estimate there could actually be up to 4,000 exoplanets within the observable range of Z-Webb. This is an estimated figure from the Leiden Project, an international collaborative astronomy initiative aimed at discovering potentially habitable planets near Earth. However, there is no guarantee that Z-Webb will detect life on other planets. Researchers say that identifying biomarkers and technology on other planets could pose a challenge in interpretation without an understanding of the potential environmental context for life. In this study, the research team identified the key indicators to examine. But on an exoplanet with different conditions, where alternative forms of life or technology might exist, those signs of life may not be so easily recognizable. Z-Webb has discovered many fascinating things about exoplanets that are close to Earth. The telescope has detected water on the exoplanet GRI 1214b, which is similar in size to Neptune and located about 45 light-years from Earth. At the same time, Z-Webb also determined that CHARBIS-1b, the exoplanet closest to the second host star in the CHARBIS-1 star system, may lack an atmosphere due to its extremely high surface temperatures. Initially, the planet CHARBIS-1b brought hope when it was discovered by NASA's TESS telescope, as it was only slightly more massive than Earth and classified as a rocky planet. This result dashes hopes of a dense hydrogen atmosphere on CHARBIS-1b, but unveils another intriguing discovery instead. The observation of CHARBIS-1b faces significant obstacles due to interference from a mysterious force, causing data disruptions, as if deliberately preventing scientists from determining whether life exists on this planet. The saboteur was identified as Saolun du CHARBIS-1, the host star of the planet. This does not mean there is an extraterrestrial civilization on that star intentionally preventing humans from exploring their world. That's because of the nature of red dwarfs. CHARBIS-1 and similar red dwarfs are known to be low-temperature stars with much weaker energy output compared to the Sun. They are also the most common type of star in the Milky Way, the galaxy that contains our Earth. New findings reveal that red dwarfs, despite being the coldest type of star, are extremely powerful, with surfaces marked by intense and chaotic magnetic activity. Perhaps it was the combination of intense geological activity and harsh radiation that left this planet barren, devoid of any trace of life. However, there remains a possibility that CHARBIS-1b possesses an extremely thin atmosphere containing water vapor, bond dioxide, or methane. This means scientists still hold a faint hope for the potential existence of life on this planet. The interference from the star also indicates that scientists need to find ways to address and propose solutions to eliminate noise signals when observing the three planets CHARBIS-1d, CHARBIS-1e, and CHARBIS-1f, planets assessed as having a high likelihood of harboring life. This telescope also detected a massive dust storm in the atmosphere of VHS 1256b, a super-Jupiter exoplanet located 40 light-years from Earth. At a closer distance, the James Webb Space Telescope observed massive geysers erupting from the surface of Enceladus, Saturn's moon. These geysers may contain chemical ingredients essential for life. Moreover, in the universe, James Webb also briefly detected carbon compounds capable of fostering life in a young star system over 1,000 light-years away from Earth. In summary, the James Webb Telescope can detect traces of civilizations within a 50 light-year radius, marking a new milestone in the quest to discover extraterrestrial life. In the future, this telescope will be used to study other star systems in the Milky Way, aiming to search for signs of intelligent life beyond Earth. Not only does James Webb search for life, but it also serves as the key to unlocking the door that helps us gain deeper insight into our own origins. By studying other star systems, we can compare the differences and similarities between planets and stellar systems. These discoveries not only deepen our understanding of the universe's formation but also lay a crucial foundation for research into the fundamental principles governing its operation. From fundamental physics laws to the origins of celestial bodies in the universe. With James Webb, we stand at the dawn of a new era, where human curiosity and the thirst for discovery will push us beyond all boundaries of knowledge. And it opens new horizons in human understanding of the universe, brimming with hope and the thrill of exploration.